All right, welcome to Next Gen Manufacturing Nexus. Today, we're going to pull back the curtain on something super fundamental, the language that actually powers all of modern making. We're talking about G-code.
So let's really think about this for a second. You've spent hours designing this perfect 3D model on your computer, right? But right now, it's just data, bits and bytes. The big question is, how do you take that digital blueprint and turn it into a real physical object, something you can actually hold, carved out of a solid block of metal or wood?
Well, you use one of these. This is a CNC machine, and honestly, the best way to think about it is like a super precise robotic sculptor. It uses what's called computer numerical control to move a cutting tool with just incredible precision, chipping away at raw material until your part is revealed. This machine, it's the magic bridge between your digital idea and the physical world.
But here's the catch. This incredible machine, it's blind. It can't just look at your 3D model and know what to do. It needs a very, very specific set of instructions, a recipe, if you will, that it has to follow perfectly. So the real question is, how do you talk to it? What language does it speak?
And that language is G-code. This is it, the universal programming language for pretty much every CNC machine on the planet. Think of it as a long list of commands that tells the machine's motors exactly where to move, how fast to get there, and the precise path to follow. It's not an exaggeration to say that this code is the very heartbeat of modern automated manufacturing.
Okay, so now that we know what it is, let's get into the nitty-gritty. Let's look at the grammar of this language. How on earth does a simple line of text make a giant machine perform a complex physical movement?
I get it. You look at a string of G-code like this for the first time, and it can look, well, pretty intimidating, right? It just looks like a jumble of letters and numbers, but there's a logic to it. You've got a G01 command that's telling the machine, hey, cut in a straight line. Then maybe a G02 command saying, okay, now cut a curve. Once you crack the basic logic, it all starts to click into place. So what's the foundation of it all? It's actually built on a simple 3D grid. You remember those XY graphs from math class? Just imagine that, but with a third dimension, Z, coming out at you. That's the Cartesian coordinate system. And here's a super cool and easy way to remember the axes. It's called the right-hand rule. Seriously, do it with me. Stick your thumb out, that's your positive x-axis, your pointer finger is positive y, and your middle finger pointing up, that's your positive z-axis. See? Every single command in G-code is just telling the tool where to go on this invisible 3D map. And the commands themselves? They're actually surprisingly simple. Let's just look at the big ones. G00 is basically go fast. It's for moving the tool into position when you're not cutting anything. Then you have G01, which is the real workhorse. That means cut in a straight line at this specific speed. And G02 and G03, those are just for cutting curves, one clockwise, one counterclockwise. And here's the really powerful part. With just those basic building blocks, a straight line and a curve, you can literally create almost any shape you can think of. Okay, I know what you're probably thinking right now. Wait a minute. Does somebody have to sit there and type out thousands of lines of this stuff by hand for a really complex part? And, well, for super simple things, maybe. But for everything else, nope, because we've entered the age of the automated revolution. Look, coding this stuff manually gives you total control, sure, but it is painfully slow. And it's so easy to make a mistake. A single typo, one wrong number, and you could scrap an expensive piece of material or even damage the machine. That's exactly why the entire industry now relies on something called CAM software. That's computer-aided manufacturing. And it's not just about speed. CAM is what lets us create those insane complex shapes, the organic curves and intricate surfaces that would be an absolute nightmare, if not impossible, to code by hand. So here's what the modern workflow looks like, and it's pretty slick. Step 1, you design your part in a 3D CAD program. Step 2, you import that model into your CAM software. This is where you become the strategist. You visually decide what tools to use, how deep to cut, all that good stuff. And then step 3, you hit go, and the software just poof. It spits out thousands of lines of perfect, error-free G-code, all on its own. The folks over at the Make YouTube channel have a great way of putting it. It's not quite like a 3D printer where the slicer software figures everything out for you. With CNC machining, you're still the strategist. You have to use the CAM software to lay out the game plan, to define the exact path the tool will take. Then, the software just handles the boring, tedious part of writing all the actual code. So there you have it. We went from typing code by hand to using powerful automated software. Problem solved, right? We're done? Not even close. The evolution of this technology is still going, and we are right on the edge of the next massive leap forward.
Because even with these amazing CAM programs, there's still a big hurdle. As this brand new research paper points out, using this software still requires a ton of technical knowledge. You have to be an expert. And that can be a huge barrier to entry for designers, artists, hobbyists, you name it. So the question becomes, can we make this even easier?
And the solution being worked on is, well, it's genuinely revolutionary. We're talking about an AI that can understand plain English. You just tell it what you want, and it translates that directly into G-code for the machine. No CAM software, no coding, just you having a conversation with the machine. So check this out. Here's how this system, called GLLM, actually works. A person just describes what they want in plain English. Something like, mill a square pocket that's 2 inches by 2 inches. The AI then generates the G-code to do it. But, and this is the absolute game changer, it then checks its own work. It runs its own internal validation, looking for mistakes, and then it corrects itself until the code is perfect. That self-correction loop is what makes this whole thing not just cool, but actually reliable.
And this is the proof right here. On the left, you see the simple text command someone typed, and on the right, the perfect toolpath generated by the AI. This isn't some far-off sci-fi concept. This is a real, tangible leap forward that could blow the doors wide open for advanced manufacturing, making it accessible to absolutely everyone.
So think about that journey. We started with cryptic, manual code, we moved to smart, automated software, and now we're on the cusp of conversational AI. It really leaves us with one huge, fascinating question to chew on. If our machines can finally, truly understand us, our plain, simple language, what's the next frontier? What does that mean for the future of making things?